Now, let us see what is Wien's displacement law. So, we have observed in Planck's radiation formula that the spectral emissive power of a black body when plotted for different temperatures. Suppose I say I am plotting for an entire spectrum. So, previously I have seen only for thermal part. Now, this is suppose entire spectrum is there. So, you see these are the maximas. We found that these maximas lie on a hyperbola like this. So, you see here this is at temperature T1, then T2, then T3, then T4. So, T1 is less than T2 is less than T3 is less than T4. So, as the temperature increasing, the lambda 1, the lambda at which they attain their maximum emissive power decreases. So, we find that these decreases and these points lie on a hyperbola. So, in order to know what will happen, when it will happen, mathematically we have to handle Planck's radiation formula. So, according to Planck's radiation formula of black body, EB lambda is equal to 2 pi C1 already seen, lambda to the power 5 exponential, that is C2 by lambda t minus 1. This is the formula. Now, in order to know when the maxima will happen, we have to differentiate. In order to find the location of maxima, we take the derivative. That means, we have to take d of EB lambda by dA alpha equal to 0. So, when we differentiate this function, no need of doing calculation, we get what is our conclusion, that lambda max. So, lambda m is the value of lambda for which the maxima occurs, maxima of the emissive power occurs, into T, the temperature of the corresponding curve is equal to B, that is constant. B is called Wien's constant. So, B value is something 0.0029. This is lambda is in meters and T in Kelvin. So, this is meter Kelvin, 0.0029 meter Kelvin. So, this is how mathematically we can get this relation from Planck's. So, this is Wien's displacement law. Thus according to Wien's displacement law, the wavelength at which the spectral emissive power of a black body the wavelength at which the spectral emissive power of a black body is inversely proportional to its absolute temperature. So, lambda max is proportional to inversely proportional to T. So, lambda max into T is equal to B, that is Wien's This is Wien's displacement law and this is Wien's constant.